All right, so this is the review for the quiz tomorrow on Friday. Number one is interesting because you could multiply x minus 3 out and get x squared minus 6x plus 9, and then move the 32 over, negative 32 over, and then use the quadratic formula. Or we could isolate the square term, divide both sides by 2, and then we would have x minus 3 squared is equal to negative 16. And then at this point, we could take the square root of both sides. We had done this way earlier in the chapter. And we get x minus 3 is equal to the square root of negative 16 is plus or minus 4i. Okay? And then all we have to do is add 3 to both sides. So we get x is equal to 3 plus or minus 4i, which is number 3. Okay, number 2, we can break this down to 49 times 2 times negative 1, right? And if you multiply those together, we get negative 98. So 7 is a perfect square, right? Square root is 49, is 7. The square root of negative 1 is I. Don't forget our negative sign out front. And the square root of 2 stays inside. So this one was number 1. So this is 3, and this is 1. All right, I didn't require to do 3 for tomorrow. This one for tomorrow. But this one we did. So you have this expression over here. 2 times 3 plus 7i. Right, that's the x. Minus 4 times negative 6 times negative 2 minus 2i. Right, we're going to use a distributive property. So we get 6 plus 14i plus 24 plus 8i. Okay, and then we can put the 6 and the 24 together. We get 30. And we can put the 14i and the 8i together and get 22i, which is number 1. Okay, on to the next page. The next page, 6, we don't have to worry about. 7, I didn't ask you to do. This one here, because the roots is an imaginary number, we know that because of the I makes it imaginary, or a non-real. They do not touch the x-axis. So this one is number 2. Okay? This one would be 0. These other two could be 2 roots, 2 either rational or irrational roots. And when we come down here to number 9, we want to know what b is. So b is tricky because the discriminant is b squared minus 4ac. And I don't know if you remember when we did quadratics with the square, it was either or. You could do all this, make this greater than or equal to 0, and you would get b greater than or equal to 10.58, and then less than 10.58. It's an or statement because they're parabolas, right? Or you could just plug them all in and see which one gives you a negative discriminant, right? Which would give you, which of the following of the b values have real solutions? We give you a positive discriminant, right? So b squared, the answer was 4. So if you did negative 11 squared minus 4 times 7, you would get 121 minus 16 minus 121. 112, right? And that's a positive number, right? That's, let's see, 9, yeah, that's 9, right? That's a positive 9. So this is the only one that gives you a positive number. The rest will all give you negative numbers, right? this is 64, which is less than 112. 9 is 81, which is less than 112, and 5 squared is also less than 112, so you'd end up with a negative number. All right, the free responses. We didn't have to do 10, but we had to do this one. So how do we solve an equation that's not a trinomial, right? How do you know? We don't have an A, we don't have a B term, we don't have a C term, and we have A as a 1/3, as a fraction. It's like a nightmare, this one, right? We do have a C term, I should say. We have a C and we have an A, we don't have a B. But we can follow our rules for solving equations and subtract 18. We have x squared over 3 is equal to negative 18. Then we can multiply each side by 3. Right, so we get x squared is equal to 3 times 8 is 24, negative 54. Oops, let me get that out of there. That's the next step. So then we're going to take the square root of both. And we get x squared. X is equal to negative 54. And this breaks down into 9 times 6 times negative 1. So x is equal to plus or minus 3i square root of 6. All right. 12 we didn't have to do. 13 we didn't have to do. $14 we didn't have to do. But this one we had to do, right? So we have 4x squared minus 4x plus 5, right? We want to know what's the all solutions. 4x squared minus 4x plus 5 equal to 0. I mean, you could do the AC method. Maybe it works, maybe it doesn't work. Maybe it factors, maybe it doesn't. You know, but it says real or complex, so I would use the quadratic formula. So I would do x is equal to negative 4, right? This is b, plus or minus the square root of negative 4 squared minus 4 times a, which is 4, times 5, okay? And if I do all this, I get 16 minus 80, all over 2 times 4. So I end up with 4 plus or minus the square root of negative 64 over 8. Right, this becomes 4 plus or minus 4 square root of, oh, not square root of, 4i. 64, square root of 64 is 8. 8i, all over 8. And then we can divide each of these by 4. So we get 1 plus or minus 2i over 2. Oh, over 4. Over 2. All right, and then you could split these. You can make this 1/2 plus or minus I. Okay, either one of these are good. Okay, so since it's an imaginary number, we know that the graph will not cross the x-axis. There's no x-intercepts. The x-axis. All right, and finally, these are the easiest ones because you don't have to worry about the b squared. It's an a term. It's not a squared term, so whatever you come out with, it's fine. So let's look at this. The quadratic equation, right, is given. Determine all the values of a that will result in the equation being a non-real solution. So non-real are determinants less than 0. Okay, so b squared minus 4ac would be less than 0, and then we would have we would have non-real solutions. So for our case, b is 10 squared minus 4 times a times c, which is 2. That has to be less than 0. It can be equal to 0. And this is 100 minus 8a less than 0. I'm going to subtract 100. And I get negative 8a is less than negative 100. And then we could divide by negative 8, divide by negative 8, and a becomes greater than 12.5. Okay, you have to flip the sign around. All right, good luck tomorrow.